Singulation is the process of dicing a silicon wafer into individual units and is a critical step in assembly and packaging. Dicing technology has continued to advance over the past 2 decades, from blade dicing to laser dicing to stealth laser, thermal laser separation, and plasma dicing. But sawing with blades remains the dominant technology for silicon glass and is the preferred choice for more than 90% of applications. One of the big things going on in the industry today is the thickness of dies. Everyone wants thinner dies so that they take up small amounts of space. This increasing demand for ever thinner dies for use in stacked assembly has pushed advances in dicing technology. Medical device and biotech applications increasingly require a lot of stacking to achieve the small dimensional sizing current applications demand. With dicing blades now as thin as 10 microns, mechanical dicing remains the low-cost option compared to various forms of laser and plasma dicing. It is also competitive with laser dicing when very thin kerfs are needed, with kerfs as small as 10 to 12 microns so you don't waste real estate on the surface of the wafer. You can design very narrow streets and make many more dies out of a wafer. So if your application requires cutting silicon, you don't necessarily need laser cutting. Blade cutting can work because the blades are now extraordinarily thin, with widths comparable to laser cutting. And blade cutting is still the economical solution with traditional thinning before dicing, even for wafers thin to membrane thicknesses of just 5 to 10 microns. Many medical device and biotech applications require thin dies, not just to reduce space, but for responsiveness as well. Responsiveness is where the die is thin to the point where it becomes a highly flexible membrane, where the silicon can move back and forth without cracking. These can be used for pumping actions when integrated into microfluidic systems and are increasingly seen in medical device applications. For applications involving silicon or glass, blade dicing remains quite competitive with laser in terms of technical capabilities, while being the faster and more economical approach. So if someone is thinking laser sounds like the right solution, then depending on what you're trying to do, blade cutting may well be the more economical approach. You don't necessarily need to go to laser cutting, even for applications down to 10 microns. This is the importance of choosing a microelectronics supplier who can bring a portfolio of capabilities and expertise for starting with a customer's wafer and processing it, to reach the ultimate objective of ending up with a die of the right thickness and shape for your specific application. At Promex, we specialize in the fabrication of complex medical and biotech devices that incorporate microelectronics. We understand your concerns and issues regarding the regulatory processes and the unique engineering demands required for medical devices and can bring a wide range of capabilities to help clients turn designs into manufactured assemblies that meet the client's technical, regulatory, time to market, and economic constraints. If we can help with your fabrication needs or to just answer an engineering question, please use the form below to reach out to someone on our engineering staff or on the business side.